Hi guys, this is your pre-learning for the P14 topic of light. Just want to talk to you here about the different aspects of this topic. So we have reflection, where the incident angle equals the reflected angle. We've got refraction, which is where light bends due to it changing different speeds, which links to how the wavefronts look. We then have lenses, which is a type of refraction. Lenses refract light. We have two types of lenses, diverging and converging. Converging lenses, you have to be able to draw a ray diagram, and then you also have to be able to calculate magnification. Then the last part is about colours and absorption, transmission and reflection. So during this video, this is just for you to get the initial notes. Please pause it regularly and you can take down any information that you wish. So just to look at reflection, you have to be able to draw this diagram. We will do a practical on this, but the angle of incidence is equal to the angle of reflection. So you need a mirror. Here's the mirror. It's depicted as a mirror by having these diagonal lines behind it. The shiny side is the side without the diagonal lines. The ray of light is this, which always has to have an arrow on it. It comes in and hits the mirror. At the mirror's surface, there'll be a normal line. The normal line is an angle of 90 degrees to the surface, or perpendicular to the surface. You can see that here. And then the ray will reflect. And interestingly about reflection, the angle of incidence equals the angle of reflection. So you need to be able to draw this. You then have refraction. Refraction is where light travels, rather than reflecting, it travels through one medium to another. So medium is what the light is traveling through. So waves pass from one medium to another and the speed changes, and this causes the angle they're traveling at to change, and this is called refraction, and it gives you strange images like this one where it looks like the straw is cut in half and moved the bottom half. This is the diagram for refraction. So refraction is responsible for things like rainbows, and you can see here that different colours of light get refracted different amounts. So red gets refracted the least and blue gets refracted the most, or violet, I should say. So here you've got your medium, you've got air here, plastic, then air. What you can see here is then the normal line is drawn at 90 degrees to the surface, so you can see that here. The angle comes in, again it's called the incident angle, the angle in. The change in medium changes the speed of the ray, which causes it to bend. So this is the refracted angle, so R in this case is refracted. And because it slows down in plastic, it's less optically able to travel. It travels slower in plastic, the light. The refracted angle is smaller. It travels through the plastic block to the other side. Again, we have a normal line. It goes back out to air and speeds up. So the angle of refraction here is greater than the angle of incidence here. And then it travels away. So you need to be able to draw this diagram, and we will do a practical. I think this word is from the practical, so just ignore this bit. So why does it change direction? Well, it changes direction because the wavefronts get closer together when they are traveling through a lens. So this is a lens. I'm just going to start the waves. As they come in, you can see they get much closer together. I'm going to restart that. I'm just going to try and increase the wavelength here. I'll slow it down a bit. I don't think frequency. Let's reduce that. So I'm going to restart it. And as the waves come in, you can see as they travel through the lens here, the glass, they bunch up. Okay, and the wavelength gets closer together. So if your waves come in at an angle like this one, what that means is it's like looking down at the top of the wave, so you're looking at the peaks. So as the peaks come in, they're a certain wavelength, so this is traveling in air. They make an angle incident with the normal, which is here. But as you can see here, part of this wave has now gone into the glass. Because the glass is optically more dense, it travels slower in the glass. This part of the wave is slower than this part of the wave. This part of the wave is slower than this part of the wave. So you can see the wavelength has decreased here, but it's the same size here. And that effect causes it to bend round. So the refracted ray makes a smaller angle with the normal because part of the wave is travelling slower, which causes the wave fronts to bend. So you need to be able to draw this wave front diagram as well. The last part I want to talk to you really about today is colours and lenses. So colours, the colours of light, the primary and secondary colours of light are different to the primary and secondary colours of paint. So the primary colours of light are green, red and blue, and I think for paint green is yellow, but for light it's different. So if you mix green and red light you get yellow. If you mix red and blue light you get magenta, which is like a pinky colour, and if you mix green and blue light you get cyan. And then you have white light in the middle, which is all the colours mixed together. Okay, so how do we see colour? Well, when we shine white light on a surface, white light contains all of the colours of light, so they're all available. If there's a white surface, then all of the colours are reflected, and so all of the colours come off and they mix together and you can see it as white. If we look at this red object, the white light is being shined on, so you've got all of the colours of the light shining in, but all of the colours bar red are absorbed. Okay, so absorbed means that the surface takes them in. The red light is the one that's reflected, so we see the object as red. If we were to shine blue light on a red surface, the blue light is totally absorbed and no colour is reflected. And so this object would look black. It doesn't look red. Okay, it looks black. You might have experienced this in quite a dark room if you've got a coloured light, like a colour changing bulb. If you turn it down quite low, because what you don't want is any other light interfering with it, so any white light. But if you turn it down quite low and maybe put it on bed and look at the blue light and then look at red objects, then they'll appear black. Anything that's black absorbs all colours of light, so we can only see it because of the colours around it. And again, you can experience that at night. Anything that's black you can't distinguish, even in a low light, between anything else that's black. So black is the total absorption of all colours and white is the total reflection of all colours. Okay, lenses. So there are two types of lenses you need to know about. The first one is a converging lens. So what a converging lens does is if rays of light come into the lens, here's the lens here, these are the rays, they're all parallel to each other, they will converge or join together at a point. That point is called the principal focus. And the point is, in this case, on this line in the middle, which is called the principal axis. It's like an x-axis on a graph, so they all join together. You can also, you need this diagram. You can also get a diverging lens. Now, a diverging lens will make the light spread out. So again, you can see the rays, ignore this bit for now, but you can see the red rays come in, they're all parallel. The diverging lens causes them to spread out. This would mean that you actually wouldn't get an image. In this one, you can get an image here. So if you put a piece of paper there, you can see what you were looking at. In this one, you won't see an image. And you can see again, the principal axis is here. And what happens is, because these real rays are not crossing, what we can do is we can draw virtual rays backwards. So not the real rays, the virtual ones. And they will cross at a point. And that would be the focal point of this lens here. And it makes a virtual focus. Sorry, and the virtual focus means that if we put a piece of paper there, we wouldn't get an image. Okay, so it's not the real image. Okay. Now, we would do loads of practice of ray diagram rules in class, but I would like you to know the rules first. So I want you to write the rules down and draw the diagram, and then in class we'll practice them. So number one, this is how you draw the rays. This lens is really big. In class, what I'll show you is that for the lens, we just tend to draw a straight line down, and that's the whole lens. You've got the focal points here. So remember, this is a converging lens. This is where the light would be focused. It's also put double the focal point on here as well, so it's twice the length. So this is the object we're looking at. Obviously it's an arrow, so in real life it would be whatever you're looking at, but it's simplified, and you can see it's 2 squares up, okay? The first ray is, the first rule is that a parallel ray to the axis is refracted through the focus. So on the left-hand side, a parallel ray to the axis. So that's this part here. And on the right-hand side is refracted through the focus, which is that line there. And you can see it bends and goes through the focus here. Number 2, the second rule, a ray to the centre of the lens passes through undeflected. That should really say unrefracted. So a ray that goes through the centre of the lens is not refracted, as you can see on this line, straight through the centre of the lens. And you'll notice they meet at a point. Now this is where our image is going to be formed. There is a third ray you can draw, but you don't have to draw it in an exam, and actually sometimes it can make your work look not quite accurate. But the third ray is the opposite to number 1. So instead of a ray parallel to the axis, it's a ray through the focus and then it goes parallel to the axis. So it looks like that one, and they've drawn it dotted because you don't actually need it. But a ray through the front focal point, because there's a focal point on both of them, will then go parallel, and they meet at this point. And this is where your image is, okay? As you can see, this image is actually smaller than the object. So rather than being magnified, it's called diminished. It's smaller than the object. It looks smaller. You need to know this diagram, and you need to know the 3 rules, and then we will practice drawing different types in lesson. Thank you. I hope you have a lovely rest of the day. Bye bye.